graduating students. So there's the 26th of the 8th 2020 Maths SS3. So we are looking at a new topic. This is week 2 basically. Week 2 period 2. Now the topic we're looking at is geometry. This topic is divided into 2 major branches. We have linear geometry, and we have circular geometry. We'll start with 2.1, that's linear geometry. And discuss about the things that we come across often in linear geometry. Now the first important subtopic we need to talk on the linear geometry is the concept of angles. Now what are angles? Angles are actually we can say it is the metric. It is a metric of the movement of a straight line. A straight line from one point to another with one of the ends of the line fixed. Good. So what are the types of angles? There are several types. We have what we call acute angles. We have obtuse angles. We also have what do you call this? Reflex angles. We have right angles. What else? Well, we can also say we also have straight line angles. Okay, these are the 5 main types of angles, but the popularly known are the obtuse, the acute, and the obtuse angles. Okay, now we are going to define each of these terms separately. So we'll start with the acute angle. What are acute angles? Now see, these are actually angles between 0 degrees and 90 degrees. Okay, angles between 0 degrees and 90 degrees are called acute angles. To demonstrate this, we are looking at angles like this, theta. Now the second case is obtuse angles. See, these are angles also, but in this case it is between 90 degrees and 180 degrees. As an illustration, we're gonna have we have the angle theta. So this is obtuse angle. The third type of angle we'll look is the reflex angle. Reflex angles, these are angles between 180 degrees and 360 degrees. Okay, they have two forms. You may have one like this, theta, or we can have this theta. These are the two possible types of reflex angles. The fourth we talk about the reflex. The fourth we'll talk about the right angles. The right angle. What is right angle? These are actually angles with a value of what? The value of 90 degrees. Okay, angles with value of 90 degrees are what we call right angles. Right angles are angles with a value of 90 degrees. For an illustration, we have this angle is supposed to be 90 degrees, so it's a right angle. Now the last type, we'll look at the angles, the straight line angles. Okay, these are angles that has value of what? Value of 180 degrees. So for instance, this is a straight line, so the angle here is 180 degrees. That's what we are saying. Good. Now we'll look into two. We've finished talking about angle. Two, we are going to look into the basic facts on angles. The first fact when it comes to angles is the fact that the sum of the angles in a straight line is 180 degrees. So if this is A, this is B, this is C, this is D, we are saying that A plus B plus C plus D equals 180 degrees. The second fact is the sum of the angles at a point, okay, is what? Is 360 degrees. 360 degrees. That is, consider this. We have A, B, C, D, E, F. We are saying that A plus B plus C plus D plus E plus F is equal to 360 degrees. Exactly. Now the third important fact we have is vertically opposite angles are equal. Vertically opposite angles are equal. Okay, consider this illustration like this: AB, C, and this D. What we mean by vertically opposite angles are equal, we mean A is equals to B, A is equals to B, and C is equals to D. Good. The last one says The exterior angle of a triangle, okay, equals the sum of the two opposite interior angles. Good. What does this literally means? It means if we have a triangle, okay, and we have this exterior angle theta, and we have this angle A and B. A and B are clearly the opposite angles to what? This side, theta. And so, by fact, we have that theta is equal to A plus B. Okay, good. Now, the third thing we are going to talk of are parallel lines. Parallel lines. Parallel lines, what will I even to say here? Now, two lines are said to be parallel. Okay, two lines are said to be parallel if they don't meet. Okay, if the two lines don't meet, they are said to be parallel. And you see, any line cutting across, I hope that's how they spell it, across a pair of parallel lines, parallel lines is termed the transversal. Good. So consider the illustration. If you consider the illustration, we assume that these lines are parallel. If they are parallel, so we can call this A, B, C, D, E, F, G, and finally H. Now, there are three different types of angles we can point out from this illustration. The first is what we call a corresponding angles. Corresponding angles are equal. First fact. So basically, what are the corresponding angles here? Excuse me. The corresponding angles are AE, that is A is equals to E, C equals to G, B equals to F, and D is equals to H. These are the corresponding angles. The second is alternate. The alternate angles are equal. We have here D is alternate to E, C is alternate to F. So we are saying directly that D is equals to E and C is equals to F. The third important fact is the sum of the interior, those are angles on the same side, interior opposite angles, yes. Sum of the interior opposite angles is 180 degrees. What do we mean by that? We mean D and F are interior opposite angles. D, C, and F also satisfies that condition. So we have D plus F equals 180, and C plus E equals 180. Exactly. Now, first example we have to find theta. We are given the illustration. I told this is theta. This is 60 degrees, 20 degrees. If these two lines are parallel. Okay. Solution. First, if I enlarge that sketch, enlarging it we have, and then I introduce some dotted line here so that this line is parallel to these two lines. Now, of course, this angle is theta, and we do know that this angle is equal to this angle, which is 20 degrees here. So this is obviously what? 20 degrees. And because we know this is 60 degrees, I mean this angle is also what? 60 degrees. Okay. So it follows that we can call this angle B, we call this angle A, okay, by alternate by the fact that alternate angles being equal, we see that A is equals to what? 20 degrees and what? B is equals to 60 degrees. And as theta is actually A plus B, we have 20 plus 60, which is 80 degrees, which is 80 degrees. And we are done with question 1. Question 2, if you are given the illustration, let's say one line here, so this is parallel to it, then we kind of have a transversal that cuts like this, such that this is a reflex angle with a value of 312 degrees, and I call this angle A, call this angle B, and call this angle C. Recall, we are saying that these lines are parallel. Now, our question is to find the unknown. Find what? Find the unknown angles. So, how do we approach this question? Very simple. As we know that angles at a point is 360 degrees. That is by sum. The sum to 360 degrees. So what do we mean? At this point, we'll say A plus 312 degrees is equal to 360 degrees. Or in other words, we're saying that A is equal to 360 minus 12. 360 minus 12, we have 48 degrees. Yeah, very correct. 48 degrees. Now, that is just A. 2 are left. Now, we do know that A is equals to B, which is what? 48%. Why? Because they are actually corresponding. They are corresponding angles. Okay. And finally, we know that B plus X, okay, is equals to 180 angles on the straight line. Angles on the straight line. Sum to what? 180 degrees. So, sorry, it's not X, it's supposed to be C. So C is 180 degrees minus B. That's 180 degrees minus 48 degrees. That's 332 degrees. Yeah, exactly. So that's question 2. Let's take another one. Question 3. If you are given the illustration, let's say, such that this apparel, and then you have this. Yes, this illustration. You are told that this is A, B, C, this is D, and this is E. You are given this angle to be 80 degrees, and you're also given this angle, this reflex angle, to be 241 degrees. Yeah, 241 degrees, and that is it basically. So these two lines are parallel. So what the question says basically that we should look for, we should find the angle, this angle. Yes, we should find the angle theta. We are finding theta, this angle. How do we obtain angle theta? Consider an imaginary parallel lines to these two lines. Then the angle, this angle, we can call this angle angle A. Okay. And the whole of this angle, we call it B. Good. Extending this line, we see that this angle is 180 degrees and this angle is 180 degrees, left with this angle of 241 minus 180 degrees. Okay, this is T, this is E, this is C, this is B, this is okay. See that this angle here is 241. You know, at D, theta is what? 241 minus what? 180 degrees, which is 61, yeah, 61, which is 61 degrees. Okay, so I think that's 61 degrees. Now, to conclude this, all we just have to do is what? Find A and B. But angle A is simply equals to angle A is simply equals to exactly equals to theta. That is, we have what? Corresponding sides. Corresponding sides. So we have that A plus 61 degrees. Also, we know that the sum of the angles on the same side of the transversal sum to 180 degrees. What are we saying? We are saying that if we consider this line and this line is parallel, angle B plus 80 degrees is equals to 180 degrees. That is, B plus 80 degrees is equals to 180 degrees. So B is 180 minus 80, which is 100 degrees. Hence, A is what? 61 degrees, and B is what? 100 degrees. Let's call it theta 1. This is theta 1 actually. So we have theta 1 equals to that, basically is equals to theta 1. Now, on doing that, to separate it from this angle, which is the real theta. Excuse. Angle theta but angle theta here is the angle B minus the angle A. That is 100 minus 61 degrees. So we have 39, we have 39 degrees as theta, and that is it.